For this video, we will again use green and blue server. We already saw how to create them in one of the previous blog posts. In this blog post, we saw how to create green and blue server, and we also have a video about the same subject. So now we have to open those servers and to log into them. After that, we will talk about JDBC. JDBC is similar to ODBC, but is specialized for Java programming language. I will now go here to terminal and I want to check what version of Java do I have. But for that I will go to File, Open Tab, because I want to run my command here in shell. So I will paste that command, I will run it, and I will see that Java is not installed. So now I will install Java. So I will use sudo apt install default Java. I will run this, I will provide my password. I will then say yes, and then we will wait a little bit. And now that this is finished, I will clean my screen. The next step is to get JDBC driver for Monet. And for that, we will go here to browser and we will go to this web page here. And on this web page, we have this file. Now this file is driver and client in one. So this is all in one solution. So this is all that we need. I already downloaded this file, so I have it here on my desktop. And then I will go here to terminal and I will run this command. So this command will use a jar file that we have downloaded to connect to Blue server. This is IP address of the Blue server, this is port number, username, and this is the name of a database. I will run this, I will provide my password, and we are now in the Blue server. Now we can try to run some query. So I will try to read from this table, and this is successful. So we are successfully using Blue server through JDBC. I will quit this session and I will clean my screen. I will then go to this first tab to mClient. We will now see how we can connect to Monet through JDBC by using dbeaver. dbeaver is SQL client with graphical interface. First, I will go again to that web page, and now I will download this file. This is pure JDBC driver, so this is client plus driver, and this is just the driver. And I will minimize this because I already have that driver here. Then I will go here to terminal, and I will go to shell, and first we have to install our program. So for installing dbeaver, I will change my current directory to desktop, and then I will download file with dbeaver on desktop by using wget. So I will run this. We will wait a little bit. Now our file is downloaded. So if we go to desktop, here is our file. Now we will use that file to install dbeaver. So I will run this command, sudo apt install, and then the name of a file. So I will run this. And now dbeaver will be installed. I will clean my screen here. And then I will go here to start button. I will type D here. And this is our program. I will click on it to open it. I will close this dialog. And then I will go to Database, Driver Manager. Then I will click on New. And now we have to provide some values. First, I will give a name to my driver. So it will be MonetDB JDBC. Then I will provide a class name. This is it. And then I will provide URL template. I will place it here. And next I will go here to Libraries tab. I will click on Add File. And now I have to find my driver. So I will go to Desktop, and here is my driver. I will click here on Open. And now I will close all of this. So I will click on OK, and then again on Close. Now I will click on this button here to create a new connection. And I will type here in the search, I will type Monet. And here is my JDBC driver. So I will click on Next. And now I have to provide some values. First, I will provide IP address of my Blue server. Then I will provide port number. Here it is. Then I will provide the name of my database. And I will provide my credentials. So my user is MonetDB and password is also MonetDB. And then we can click on this button test connection. So I will click here and this is successful. Now, if you have a problem to connect like this, then you can change this setting to URL, or you can leave it as host. So if this is working, then it is okay. If it is not working, then use URL option. I will now click on finish. And now here we have our database. I can click here and now here we can see our schemas, tables, and so on. So we can use dbeaver to manage our Blue server. I will close dbeaver and I will go back to terminal to mclient. Now we will talk about recursive common table expressions. Let's assume that we want to take a shower and we want to set the temperature of water to be warm. So in our faucet, we will move the lever to the left, to the right, to the left, to the right until we find the perfect temperature. So recursion is one iterative process where we are applying the same logic in each step, but that logic is based on information that was acquired in the previous steps. So in each step we will get better and better result until we get the result that we are satisfied with. Let's take a look at one more complex example. Let's assume that our friend imagined a number between 1 and 10, and we want to guess that number with the least amount of questions that have yes/no answers. And the best approach is to use binary logic. We will ask questions that will halve the range of the possible numbers each time we make a question. So if this is a list of our numbers, initially we will ask a question, is that number bigger than 5? If it is, then the number must be between 6 and 10. Next question is it bigger than 8? If it is not, then it has to be 6 or 7. And then we will ask, is it smaller than 7? If it is, then it has to be 6. So our algorithm is like this. We will always check whether the result set has only one number. If it has only one number, then that is the final result. If it doesn't have only one number, then we will ask a question, and that question will halve the range of the possible numbers. Now, this second step can be presented as one function. Well, let's call that function eliminate half. When we apply that function on the initial set, we will halve the range of the possible numbers. We can use it again to get only 6 and 7, and we can use it the third time to get the final result 6. We can even represent this process as nested functions. But there could be a problem. Sometimes we do not know how many steps do we need. In this example, we could guess the number of steps, but sometimes we do not know. So I have created one pseudocode example that will show us how we can find the solution when we don't know in advance how many steps do we need. So first we will set initial state. So this is initial state, and in each iteration of this loop we will eliminate half of the numbers. And when we do that, we will check whether our final goal is satisfied. If it isn't, we will continue with halving until we met this condition. And at the end, we will have our result. So that is recursion. So we are constantly repeating the same action, and we will use the result that is from the previous steps. One example could be, for example, a football team coach. That coach, after each game, will analyze the game of his team. And then he will improve the game of his team, and that will be repeated after each game. So he will constantly improve that game until he became satisfied with the game of his team. So the structure of recursion is like this. We first set initial values, and that initial value represent the initial state. And we want to improve that state. First, we will ask a question. If this initial state is already satisfying, if it is, then we already have the final result. But if it is not satisfying, then we have to improve it. And we will repeat these steps 2 and 3 until we reach the final result. Let us now talk about linear and tree recursion. If we have linear recursion, that means that we only have two options. We can improve our status or we can be satisfied. For example, coach can be satisfied with his team or he can improve his team. But if the coach has more opportunities, then he can choose between them. For example, coach can improve the game of his team or he can look for a job in some other team. In that case, we can create a diagram of his career, and for that we can, for example, follow red path. Red path means that coach is satisfied with Real, he is working for Real, but then he will change his team. He will go to Arsenal and then he will start improving Arsenal. Here we can see this plus. Plus means that he improved the game of Arsenal. Then we have orange path. He can work for Real, then he can go to Arsenal for a short time, then he can go to Barcelona, and then he can start improving Barcelona game. Or purple path means that he will go from Real to Liverpool, he will improve the game of Liverpool, then he will go to Juventus, and he will start improving the game of Juventus. We can present this career of our coach as folders and subfolders. For example, if this is Real, if coach is improving the game of Real, then he is going vertically down. So he is going here to Real Plus. But if he is changing his team, then he is going horizontally to Juventus. So that is why we call this a tree recursion, because there is a hierarchy, and this hierarchy is consequence of the fact that our coach can make decision that will lead his career in different directions. But each time when we want to change our career, we will use the same logic. We will ask ourselves, should we stay and improve our team? Are we satisfied with our team, or we should go to some other team? Now that we understand recursion, let's see how to use recursive common table expression. We will take a look at this image here. Here we can see a general form of recursive common table expression. We have one CTE with this name, and inside of it we have two select queries. The first select query will define initial state. This second select query will read from that initial state, and it will make some modifications, some improvements to create a new state. So new state will be created, and then that new state will become a state with this name. So new state will replace a previous state with this name. So all of them will use the same name, but after each iteration, a new state will become a state with this name. And we will also ask, is our improvement satisfying or not? If this returns true, then we will continue with recursion. So we will again read from this now second state, we will improve it, we will create third state, and we will check if it is satisfying. If it is not, then we will create fourth state, and so on. Now let's take a look at one working example. I will go here to terminal and I will paste here my statement. Here we are starting with number 1. This is our initial state, and that initial state now has name numbers. Then we will read from that initial state and we will make an improvement, and we will also ask if that initial state is satisfying this result. If it is satisfying, then we will continue with recursion. So first improvement means that now this value is 1 plus 1, that is equal to 2. And that new state will now become numbers. And then we will call that second state, so from numbers, and we will again improve it. So, but now we will have 2 plus 1, so we will get 3. That is satisfying this condition. So again, we will continue to cycle. So now n is equal to 3, so 3 plus 1 is equal to 4, and so on. And then we will use union all to connect all of those states. Let's see what will be the result. So the result will be numbers 1, 2, 3, 4. We can better understand that if we go to this web page and we go down here. Now this first select query is anchor, that is initial state, and this is recursive member. This recursive member will calculate all of other states. So based on the state n is equal to 1, we will calculate that n is equal to 2, that it is equal to 3, and so on. So these are basically tables. We will then use union all to connect all of these tables like this, and this will be our final result. Let's take a look at one more example. We will now see how to calculate factorial by using recursive CTE. So this is an example that will return some numbers in order, and it will return factorial values. So this first column is calculated the same way as this previous example. We have initial state 1, and then we are using n plus 1. So we are just increasing this number. But this part here will start with initial value, and for this initial value, next number is the same number increased by 1. So we will increase that value by 1, and then we will multiply that with the previous number. Previous number is 1 because we start with 1. So this will be 1 times 1 plus 1, that is 1 times 2. So now the state is 2. So fact becomes 2. So 2 times 2 plus 1, so this is 3. So 2 times 3 is equal to 6. And 6 times 3 plus 1 is equal to 24. And so on. So we are getting this sequence here. We can see how this is calculated by looking at this image here. So we will get all of the factorials for these numbers. I will now go back here to terminal and I will clean my screen. Let us now see one example for tree recursion. So I will go here below, and here we can see a hierarchy of folders and subfolders. We can represent this hierarchy inside of Monet like this table. So for each possible folder, in second column we will see its parent. And I will now create this table inside of Monet. So I will go here to terminal, and I will first create a table, and then I will insert the values inside of this table. And then we can read from this table to see is that table the same as the one that we saw on the image. So it is the same one. But now I will run one recursive CTE that looks like this. I will run it, and this is what I will get. So for each element we will see its path that explains its position in a hierarchy. So how is this working? Well, for that we will again go to this web page, and we will first start with initial state. In initial state we will look only for top folders. So top folders are the one where parent is null. So we will only take these two elements. So we will get this result. So this is our initial state, and we know that for top elements, path is only that element repeated again. So we now solve the problem for the top elements. Now, how to find elements that are below? How to find folders that are here? Well, for that we will start with this, our table. So this table here is the same as this table, and we will create a join with this table here. So this join is explained here, and we will join them based on the fact that parent of these folders here is equal to folder that is in this first column in this first state. So that is how we will define all of the elements that are in the middle level, because their parents are equal to the top elements. And based on that, we now have a connection with which we can see for these elements who is their parent, and then we can use path of their parent, which is just the parent itself, and on that path we can add this element here to create a new path. So this is the path for the middle elements, for these middle folders, and then we will repeat this process. We will take this result, we will join it again to that initial table, we will use inner join, we will search for elements whose parent is equal to one of these middle folders, and when we find that connection, then we can use the path of that middle folder. We will continue that path with our element that is at the third level, at the bottom level, to get the new path. And now here we have top level folders, here are middle level folders, and here are bottom level folders. And now we can union these three tables to get this as a final result. So this is our anchor member, and these are two recursive members. With each recursion, we are getting next level. So we start with this as initial state, then we go to middle folders, and then to the bottom folders. And each time we calculate these paths. I will now go back to terminal, and I will clear the screen. We will now talk about some recursive CTEs caveats. First, when we create recursive CTE, we will have anchor member and recursive member, and they should match in number of columns and in their data types. Second, when we are creating recursive CTEs, we can use union instead of union all. But in that case, the first time we met a duplicate value, our recursion will stop. And it will stop even if we do not have where clause inside of the recursive member. I will give you an example for that. So I will show you this statement here. And here anchor member will return number 1. And then first recursion will also return number 1, which is a duplicate. And at that time, our recursion will stop. And then union will remove one of these duplicates, and we will get only one row as the result. And this is that result. Third, we should never use outer joins in recursive CTEs. We should always use inner join. If we use outer joins, then our CTE will never end. It will go in infinity. And fourth, in Monet, we can use aggregate functions and window functions in recursive member. We can also use distinct and group by in the recursive member. We can use CTE, recursive CTE in the from clause, and we can also use it in the subquery. And some of these things are not allowed in other servers. I will now clear my screen. We will now talk about some new functions in Monet. And first we will take a look at dayname function. This function accepts only one argument, and that argument can be date, timestamp, or timestamp with time zone. And if we use this function, we will get the name of a day of a week. And this name will be in the language that is set in regional settings of the operational system. And function similar to that is month name. And for this date, this function will return July because that is the 7th month in the year. So we will get July. I will now clear my screen. We will now talk about generate series functions. I will give you one example. Here is a function that will create a sequence of numbers. Numbers will be between 1 and 9. They will include 1, but they will not include 9, and the step is 2. So if I run this, we will get number 1 because it is included, then we will have 3, then 5, then 7, and we will not take number 9. It is also possible to create a sequence of dates. We will use the same function, but this time we have arguments that are dates. So we are looking at range that is between 1st January and 10th January. Our step is 5 days. So if I run this, we will get the 1st January, and then after 5 days we have 6th January, and that is our sequence. Besides using days, we can also use months. So I will give you this example. Again, we have two dates. We have 1st January and we have 10th May. Our interval is 2 months. So if I run this, we will get 1st January and 1st March. Besides using dates, we can also use timestamps. So here is another example. This time we have 2 timestamps. This first timestamp ends with 00 seconds, and this timestamp has 05 seconds. Our step is interval of 3 seconds. So we will get this timestamp with 00 seconds, and then after 3 seconds we will get 03 seconds. We can also use day as interval with timestamps. So here is another example. Again, we have 2 timestamps, and then we have interval of 3 dates, and as a result we will get these 2 timestamps.